Okay, law of cosines. So similar, in I guess its use, we can use it to help us solve triangles, just depending on which information we're given. So the law of cosines, both of these I think are, well, maybe only one form of the law of cosines is on your formula sheet, but it's all pretty relative. So we could say a squared is equal to b squared plus c squared minus 2bc cosine A. Okay, that's probably the only thing that's on the formula sheet. All right, but if we just alternate the places of A, B, and C, because like I said, they're all kind of arbitrary, what we call A, B, and C. So I could say B squared is equal to A squared plus C squared minus 2AC cosine B. All right, or what? C squared would be equal to A squared plus B squared 2AB cosine C. Okay, so again, you'll probably only see this one on your formula sheet. You can check it now to see what's there. But if you have that one, you ought to be able to, if it doesn't match or you can't remember, then just relabel the sides and angles because they're all, at this point, arbitrary. Okay, since we are not doing right triangle trigonometry anymore. So solve each triangle. We've got two sides and the opposite angle, or rather, I'm sorry, the included angle. So I'm going to start by finding side B. So I'm going to say B squared is equal to A squared plus C squared minus 2AC cosine B, or 2 squared plus 1 squared minus 2 times 1 times cosine of 10 degrees. Okay, I just plugged in the values, yes. How do I know if I'm going to use the law of cosines or sines? Just the information that was given to me. So I couldn't use at this point the law of sines because I don't have an angle and the opposite side. I had angle B, but I really don't have any way of finding side B yet, except to use the law of cosines. Okay, good question. I think that's kind of the where people start saying is it angle, side angle, whatever. But you really need to look at the information that you're given and decide which formula is appropriate to use. Okay, so we put all that on the calculator. So I've got 4 plus 1 is 5 minus 4 cosine of 10 degrees. 4 times cosine 10 degrees. So I got 1.066, that's B squared. So B is 1.02. I'm going to store that as alpha B. Right? Okay, B squared was 1.06. B is 1.02 dot dot dot. Okay? So now I do have an angle on the opposite side, so I drop back to the law of sines. You could use law of cosines all the way through, but law of cosines won't produce for us a second triangle, which there could be, because when we talk about where cosine is positive, that's the first quadrant and the fourth, and we're not going to have angles in a triangle from the fourth quadrant, right? So we have to go back to the law of sines to make sure we get everything. All right. All right, so I'm going to do sine A over side A, which was 2, is equal to sine of 10 degrees, that's my angle B, over 1.02 dot 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 dot. Okay? So sine A equals 2 of sine of 10 degrees over 1.02. Okay? And I mean, just again at this point to minimize, how many times. Well, no, let's type it out because I don't know what it is. So we're going to do 2 times sine of 10 degrees divided by alpha b. We get 0.337, right? That's acceptable. Sine A equals 0.337. So to get angle A, we do what? Sine inverse. Second sine inverse, second answer. So A equals 19.7 degrees, approximately. Okay. All right. So I've got. So if we don't store that, we get the wrong answer. Right. If you round off, you can, especially when the numbers are small, these things, are very sensitive. I got side B, I've got angle B, I'm sorry, angle A. I need to ask myself at this point, is there a second possible angle? Okay, so we came up with 19.7 degrees over here. Okay, so a reference angle of 19.7 degrees over here, that's going to be 180 minus, I'm going to store this. This was alpha A. Oh, that's not what I did. Clear. Store. Clear. Alpha A. Okay, there we go. So I'm going to do 180 minus alpha A, or 180 minus alpha A. All right, we get 160.29. So we could have an A prime of 160 point, let's say, 3 degrees. We'll just do dot, dot, dot. Is that feasible? 160 plus 10, that could work, right? Okay, in this case, if we're going with this angle, C is going to be 180 minus 19.7 minus 10. Right? Y'all should be refreshed today. No? Alpha A minus 10. Okay, C could be 150.29 degrees. Okay, or if we use this second angle or value for A, it'd be 180 minus alpha A, right? Or is that the same one I just did? Let me just type it out. 160.2935 minus 10. Did I do that right? Y'all don't know. I subtracted, this is angle A, and then I wanted to subtract B. So we would get C would be 9.7065 degrees. Okay, is that feasible? Looking back at our lengths, what's our largest side? A. So it needs to be opposite the largest angle. Okay? When I compare this scenario, we got that C was equal to what? 150.2. Okay? Is the largest side opposite the largest angle? No. So this one won't work. That was the first one that we got. It doesn't work. Okay, but then when I compare it to the second, here my largest side would be opposite my largest angle. Okay, and also the smallest side, which is C, needs to be opposite the smallest angle. That works. Okay, so this would be my correct answer along with B. Questions about that? Questions? Okay. Well, at this point, I could tell because my largest side was not opposite my largest angle. My largest side is A, is 2, and in this scenario, the largest angle was C. So that won't work. Okay? But in the second scenario, we were able to get the largest angle to be opposite the largest side. So this one works. Okay? That has to happen. All right, other questions? Questions? Okay. All right, B, second scenario, and it may work out a little easier for us. Let's see. This time we got three sides. All right, and that will always start out with the law of cosines. All right, we can figure this out with the law of cosines because in that formula, it takes into consideration all three sides. The thing that'll be unknown will be an angle. Okay, so it doesn't matter which angle we solve for first. So I'll just start by saying a squared equals b squared plus c squared minus 2bc cosine a. All right. So we get 4 squared equals 3 squared plus 6 squared minus 2 times 3 times 6 cosine A. All right, the only thing that's unknown is angle A. Okay. Does that make sense? Okay, so we got 4 squared minus 3 squared minus 6 squared equals negative 36 cosine A. All right, so 4 squared minus 3 squared minus 6 squared. I got negative 29 equals negative 36 cosine A, or cosine A equals 29 over 36. Okay, I can already tell that that's between minus 1 and 1. So we get A equals cosine inverse of 29 over 36. So I get 36.33. I'm going to store that because I may need it. I don't think I did that right. Clear. Store. Okay, got it. Okay, so we get 36.33. A equals 36.33. That's degrees. Okay, so now I do have an angle on the opposite side, so I could go back and use the law of sines. Okay, so we can say sine B over 3 is equal to what? Sine of 36.33 degrees over what? 4. Okay, very good. So sine B equals 3 times sine of 36.33 degrees over 4. So we get 3 times sine of A divided by 4. So 0.444. All right, and then I'm going to do sine inverse of that. We get B equals 26.4 approximately, right? Okay. Is there another feasible answer? We have to ask that question every time. All right, so from here, we got 26.4 degrees over here. What angle has a reference of 26.4 degrees? 180 minus 26.4 is what? Okay, so can we do 153.6 plus 36 and still be okay? No, that's over 180, right? So I don't have to worry about this angle. Okay. Having a brain freeze. So then we're almost done. The last thing we need to find is what? C. And we can do that by saying 180 degrees minus B minus angle A. So 26.4 minus A. All right. Oops. Second clip. Minus alpha B. Did I store it? I don't think I did. Did I? There it is. 26.3824. Who has the answer? What's B? What's C? 117.26. Okay. 117.26 degrees, we'll say. Okay, so we check to make sure that the largest angle is opposite the largest side. C is the largest side. The largest angle is C. Smallest side is B. That should be our smallest angle. That's the case. So we found all of our solutions. A, B, and C. Okay, questions about that?
How do you decide when you do the a squared equals b squared plus c squared and all of that?
How do I decide which part?
Like when you do.
Why did I use that formula?
Instead of like what we did like on the first half with sine a over a.
Based on the information that I have. In order to use the law of sines, I have to have a side and the corresponding angle.
Okay.
So I don't have that here. I just have 3 sides.
Okay.
Okay? But in order to use the law of sines, once I got side A right here, then I could use the law of sines because I had a side and the opposite angle. I knew side A and I also knew angle A. But we can't use the law of sines until we have a side and the opposite angle. Okay? Other questions? Okay, very good. All right. So just a few little word problems and yeah, that's going to be it. Ooh, 3-word problems. Yeah, we already did the area of a triangle, right? Okay. All right. An airplane flies due north from Fort Myers to Sarasota, a distance of 150 miles. Okay, we got a nice picture here. Okay, and then turns through an angle of 150 degrees. Okay, notice the turn. And flies to Orlando, a distance of 100 miles. How far is it directly from Fort Myers to Orlando? Okay, so what information do we have here? And what are we trying to find? Okay, we're trying to find this side. Okay, I'm going to call it S since it's opposite Sarasota. Okay, so this included or opposite angle is 130 degrees. Okay, and also I have what? Two sides, right? Okay, we got side angle side. I'm trying to figure out the other side. Um, since I don't have any other angles, the only thing I can do is the law of cosines, right? Okay, we've got one angle measure, but the side that's opposite is unknown to us. So we can't use the law of sines. We have to use the law of cosines. So I'm going to write it out as s squared is equal to what? Okay, what are the numbers from our picture? 150 squared plus 100 squared minus 2 times 150 times 100, what else? Cosine of 130 degrees, the angle at Sarasota. Does everybody see why we plugged it in that way? Yes? Okay. All right, so I've got 150 squared plus 100 squared minus 2 times 150 times 100. Okay. And is that the squared number? Okay. So we get this number for s squared. I'm going to take the square root of that. So we get 227.5.6 miles, we'll say. S equals 227.6 miles. Questions about that? Okay, very good. Questions? Okay. Would that be what? What was the question? Oh, I forgot. What bearing should the pilot use to fly directly from Fort Myers to Orlando? Okay, so we said bearings were measured how? Remember we talked about that last week? We said from a north-south line, right? So what we need to do, I thought that was too easy. Uh, so yeah, we need to find this part. We need to find this angle, right? Okay. So how could I find that angle? Using what? The law of sines, right? Let's call this F for Fort Myers. Then I can say sine F over what? Over 100, that's the opposite side, is equal to sine of 130 degrees over what we just found, 227.6, dot, 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 dot. Okay, all the bits and pieces. So we get sine F equals 100 times sine 130 degrees over 227.6. Okay, so when we do that on the calculator, we've got 100 times sine of 130 divided by second answer. Is this still there? Okay, so I get sine F is equal to 0.3366. So F equals sine inverse of 0.3366. Okay, we get 19.6. Okay, 19.7, let's say. All right, so we would say the bearing needs to be north 19.7 degrees east. Okay, remember when you hear those words bearings and headings, if we need to, we go back to the definitions, which we talked about last week. So I'm going to refresh my memory because I do forget sometimes. Oh, there it is. Okay, bearing is measured from a north-south line. Okay, so this is bearing. If it had said heading, then we'd need to do it slightly differently. We'll come back to that in a second. Remember, we said the heading was measured from the north clockwise. All right, so it'd be just a little minor adjustment. We'd have to figure out in this case, it would just be what? The angle. It'd just be 19.7 degrees. It's not always the same thing. Okay, but from the north clockwise would still be 19.7 degrees. Okay, if it said heading. This is a bearing. Okay, or heading of 19.7 degrees. But they're not always the same. Okay, very good. All right, why don't you take a look at this one on your own, okay, to kind of get slightly acclimated to what's there and get your thoughts together. Okay, so we're trying to fly from Chicago to Louisville, but he takes the wrong path. He's off by 10 degrees as shown in the figure. Okay, if the aircraft maintains an average speed of 220 miles per hour, okay, and if the error is discovered after 15 minutes. So what do we use that piece for? Okay, to find how far he traveled in the wrong direction, right? Distance is equal to rate times time. So he's going at a rate of 220 miles per hour. Okay, he does that for 15 minutes, which is how much of an hour? 1/4 of an hour. So he travels 55 miles in the wrong direction. Okay, so we got that side is 55 miles. So now we've got a side, an angle, and a side. Okay, so everybody got that far? Okay, good. All right, through what angle? So we're trying to figure out which angle, and they show us the angle right here, which note that that angle is not inside of the triangle. All right, that's kind of outside of the triangle, but that's the measure in which he's going to need to turn. So what I need to figure out is what? I got 55. I got two sides. So what do I need to figure out? I guess I need to figure out this angle. Okay. I've got the opposite side, and then I've got this side, but I don't know any other angle measures. So what else do I need to know? Or am I ready to set something up? What'd y'all do? Okay, we need to, that would help us. We could do that. Okay, we'll call that C since it's opposite Chicago. So we can say C squared is equal to 330 squared plus 55 squared minus 2 times 330 times 55 cosine 10 degrees. Okay, and so we do 330 squared, oops, plus 55 squared minus 2 times 330 times 55 cosine 10. Okay, so once he gets things corrected, the distance that he's going to need to travel is 276 miles. Okay, so I'm going to store that as C. Okay. All right, now that I know that, I've got a side, the opposite angle, and I've got an unknown angle and the opposite side. So I can say, what are we going to call this one? Let's just call him, guess we'll call him theta. Okay, theta is right here. So I can say sine theta over 330 is equal to what? Sine 10 over, what was it? 276, okay. 276. Okay. So sine theta equals 330 times sine 10 degrees divided by the 276 number that we just found. So 330 times sine of 10 degrees divided by second answer. Okay, I get 0.208. Sine theta equals 0.20, I'll say 0.207 dot dot dot. Okay, so theta equals sine inverse. 11.98. Okay. All right, so that's theta. Is that our answer? No, because he's making his turn out here, right? 180 minus that would give us the angle through which he needs to turn. Okay, also, we do need to, and I'll just kind of spare us doing this because I know it won't work out. We would need to consider the other answer, right? We could have a theta prime that would be 180 minus 111.98. And we end up finding out that that one won't work, I think. But anyway, to get our answer, it's going to be 180 minus 11.98 degrees because the angle's on the outside. Turn is how much? 168.02 degrees. Okay, questions about that? Yes. hmm Not checking mode. Mode. Yeah. Okay. And then they ask, okay, what average speed? Is that what they ask us? What new average speed should the pilot maintain so that the total time of the trip is 90 minutes? He's already traveled 15 minutes. We've got 75 minutes left. So still, distance equals rate times time. Okay, we're asking about the average speed, so the rate is going to be distance divided by time. We got 276 miles divided by 75 minutes, which is what? 1.25 hours, right? Nobody agrees with that? Y'all thinking about it? Okay, if you need to convert it, right? Everybody okay? 75 minutes. That's minutes. 60 minutes in 1 hour. So 1 hour. So that comes up to be 1.25 hours. Okay, so 276 divided by 1.25 gives us 220.8 miles per hour, which is not bad. It's almost that far to Atlanta. It only takes you about 45 minutes. So, okay. Questions about that? Okay, very good.